we are Group 11 from 1AR4, and today we are going to be discussing about solids of revolution, which are ring torus, ellipsoid, and paraboloid. Let's get started. So a ring torus is simply a donut. So the plural form is tori and not toruses, and it comes from a Latin word which means cushion. A ring torus is formed by having a smaller circle, symbolized by the lowercase r, revolve along a line made by a bigger circle symbolized by the capital letter R. So I use an ellipse here to achieve a 3D effect. So let's move on to the formula. We have two formula. The first one is for the surface area, which is 4 times pi squared times major radius times minor radius. The second formula is for the volume, which is 2 times pi squared times major radius times minor radius squared. Now I think you're ready for the application. Let us answer the problem. A bakery was tasked to fill and pack a batch of donuts with only measurements as basis. One donut has the following radius, 36 millimeters and 12 millimeters. It was also specified that one donut should be filled throughout and packed tightly. How much filling is needed for each donut? How big should the packaging be? So let us first list down the given values. So we have the following radius, 36 millimeters and 12 millimeters. So always remember that the bigger number is the major radius, which makes up the part of the center of the torus and the center of the ring. So it's right around here. While the minor radius is simply the radius of the ring. So this is 12 millimeters. To solve for the amount of filling needed for each donut, we are going to use the formula for the volume. So let us directly substitute the following given. So we have 2 pi squared times 36 millimeters times 12 millimeters squared. So you can actually input these values on your calculator, but let us simplify. So now we have 2 pi squared times 36 times the square of 12 millimeters, which is 144 millimeters squared. Simplifying even more, we have 2 pi squared times 5,184 millimeters cubed. Entering these values into your calculator, we come up with a volume 102,328.06 millimeters cubed. To compute for the size of each packaging, we will use the formula for surface area. So directly substituting the values we have, we come up with 4 times pi squared times 36 millimeters times 12 millimeters. Simplifying the values, we come up with 4 pi squared times 432 millimeters squared. Entering these values into your calculator, we come up with the surface area of 17,054.68 millimeters squared.
Circular paraboloid. So, a circular paraboloid is a parabola that rotates on its axis of symmetry. So, the parts of a circular paraboloid is its radius and its height, and the axis of symmetry right down in the middle. So, the volume of a circular paraboloid is 1/2 pi times height times its radius squared. For the application of the circular paraboloid, find the volume of a vase with a radius of 5 inches and a height of 23 inches. Will this fit 25 to 30 stems of flowers that has a diameter of 1 inch and a height of 31 inches? There are two unknowns for this problem. The first unknown is the volume of the vase, and the second is the volume of the flower stem. First, let's solve for the volume of the vase. For the volume of the vase, we were given a radius of 5 inches and a height of 23 inches. So, in this problem, we just directly substitute the given values and you get 903.21 cubic inches for the volume of the vase. For the volume of the flower stem, we are given a diameter of 1 inch and a height of 31 inches. So, We can't directly substitute because we were given the diameter and not the radius. To get the diameter, we just use 2 pi r and convert the diameter into its radius. So the radius is 0. So you just divide 1 inch by 2, so you get 0.5 inches. And now you can substitute the given values. So the volume of the flower stem of one flower stem is 24.35 cubic inches. So the question is, can the vase fit 25 to 30 flower stems? To answer that question, I just multiply the volume of a flower stem to the needed quantity. So 24.35 times 30 will give you a total of 735 cubic inches. So yes, the vase will fit 30 flower stems or more because the volume of a vase is 903 and the total is 735.
So I'm going to report the ellipsoid. So what is an ellipsoid? It's also known as a spheroid. It's a closed surface of which all plane cross-sections are either ellipses or circles. An ellipsoid is symmetrical about 3 mutually perpendicular axes that intersect at the center. So as you can see there's 1, A, 2, B, and then C, 3 axes that all intersect over here at the center. So there are 3 types of ellipsoids. The general one, whereas A has a different measurement to B and to C. But then there are 2 others, whereas oblate looks like this. The place that takes up B is equal to A. So it's just A squared when it comes to the volume. So the volume of this general one is 4 over 3 times pi times A times B times C. Whereas this oblate one is just 4 over 3 times pi times A squared times B. And the other one is prolate, where it's taller. So the volume of that is 4 over 3 times pi times A times B squared. And then there's this one formula for the surface area called the Nod-Thompson's formula. The surface area of a general ellipsoid cannot be shown through elementary function, but it can be expressed through this approximate formula, as you can see over there. Yes. Next. So for the application, find the volume of an M&M that has a major axis of 20 millimeters and minor axis of 14 millimeters. So based on the given, you can tell that an M&M is an oblate sphere, ellipsoid, excuse me. The formula we'll use would be 4 over 3 times pi times A squared times B. And we use the formula of an oblate ellipsoid. So it becomes 4 over 3 times pi times 20 squared times 14. So the answer would be 23,457.23 cubic millimeters.
Hey guys, I'm Enzo Villanueva, and for the bonus round, we are going to be answering this problem over here. If the editor will add it. If not, I'm gonna be reciting it. So find the surface area and the volume of one Enzo cereal with a radius of cross-section R of 1 cm and about a line 3 cm from the center of the cereal. So we know that the big R is the major radius and the small r is for the minor radius. So solving for the surface area, we got 4 pi squared major and minor radius. So we just plot the details. 4 pi squared, the big R, which is 3 cm, so 3, and the minor, which is 1. So we plot it in the calculator. So we get 118.44 cm. And for volume squared. And for volume, we have 2 pi squared major minus radius squared. So we plotted 4 pi squared, 3, and 1. So in the calculator, so we get 59.22 cm cubed. And there we get the final answers. And that's it for the final round. Thank you!